Hey there, and welcome to The Explainer. Today, we're diving into something you have probably been hearing a lot about lately, artificial intelligence. We're going to break down exactly what AI is, where the idea even came from, and how it actually works out there in the real world. We'll look at how brilliant minds have tackled this massive puzzle over the years. So let's just jump right in.
Think about this for a second. How do you actually make a machine think? Seriously, this isn't just some coding puzzle. It's literally the core philosophical question that's been driving computer scientists crazy for decades. Do we try to build a mechanical brain that perfectly mimics human biology, or do we just focus on getting the right answer at the end? It's a question that completely changes how you build an intelligent system.
So, here's our game plan for today's explainer. First, we'll look at the core concept of AI. Then we'll walk through the timeline of AI, and finally, we'll explore the main fields of application. All right, Section 1. The concept of AI, the evolutionary analogy. To really wrap our heads around what AI is, we have to look at this absolutely brilliant analogy from the source material about how we invented flying machines. It totally changes how you look at machine intelligence. You see, for centuries, humans wanted to fly, right? And the earliest attempts literally just tried to copy nature. Inventors would strap on wings and try to flap them like a bird. But we didn't achieve artificial flight by perfectly replicating a bird's flapping wings. No way. We did it by mastering the end result, staying up in the air using totally different mechanics, like aerodynamics and fixed wings. The airplane flies incredibly well, even though its engine and wings look absolutely nothing like a bird.
And honestly, that perfectly illustrates our definition of artificial intelligence. The absolute key takeaway here is that AI is defined by its external behavior and its results. When a machine solves complex math, beats a grandmaster at chess, or diagnoses a disease as well as, or even better than, a human doctor, we call it intelligent. We're not opening it up to see if its processing perfectly mimics the neural pathways of a human brain. Just like the airplane, it is evaluated by its ability to achieve human-like or superior results, regardless of what's happening under the hood.
Moving right along to Section 2, History of AI Formation, From Theory to Reality.
Let's look at a quick timeline of how we got here. We'll start way back in 1943 with the very first neural models, then move to 1956 when the term AI was actually invented. From there, we'll jump to the 1970s with the rise of expert systems, and finally land in the massive data mining era of the 1990s and 2000s. Let's break these down. The whole story really kicks off in 1943. Two researchers, Warren McCulloch and Walter Pitts, came up with the very first artificial neuron model. They gave these fake neurons super simple on and off states, basically like little biological light switches. But the real magic happened when they realized that networks of these simple switches actually had the capacity to learn. This was huge. It proved that a machine could theoretically be taught, which basically lit a fire under the entire scientific community.
Then comes the summer of 1956, a total watershed moment. At the very first conference completely dedicated to this new field, a scientist named John McCarthy officially coined the term artificial intelligence. So he literally gave the field its name and its identity. And as if that wasn't enough, around this same time, he also proposed Lisp, which ended up being one of the foundational programming languages for AI research for decades. Talk about a productive summer.
Around this same era, we also have the brilliant Alan Turing, who introduced what we now call the Turing test. Now remember our airplane analogy where we define AI by its results? Turing basically created the ultimate benchmark for that. He proposed a test to verify if a machine was actually acting intelligently. The gist is, if a machine can respond to questions in a way that makes it completely indistinguishable from a real human, boom, it passes the test.
Fast forward to the 1960s and 70s, and we start seeing some incredibly rapid, specialized advancements. We've got Joel Moses writing Maxima, which was the first really successful math program using a knowledge base. You've got Marvin Minsky and Seymour Papert doing the hard math to prove the limits of simple neural networks. Ilan Kolmar developed Prolog, a massive leap forward for automated logic. And Ted Shortlift built MYSyn, the very first medical expert system designed to actually help diagnose diseases. Instead of trying to build one big brain, the field was splintering into these super useful specialized tools.
And that exact shift sets the stage for the massive boom we saw from the 1980s right through the early 2000s. Scientists kind of realized that building a fully generalized human-like brain all at once was incredibly difficult. So they put that dream on hold and focused on specific, solvable subproblems. Combine that focus with skyrocketing computing power and some really rigorous math, and AI just exploded. We started simulating human expert knowledge and applying these solid mathematical methods to mine massive amounts of data across pretty much every industry you can think of.
Which brings us to Section 3, Application Fields, the branches of AI.
So, why does all of this matter to us today? Well, because AI isn't just one big monolithic brain in a jar anymore. It's more like a giant tree with all these different branches, covering an entire landscape of technology. We're talking automated reasoning, robotics, knowledge representation, planning, machine learning, natural language processing, and expert systems. Every single time you pick up your phone or use a computer, you're probably touching one of these branches. Let's zoom in on a few of the biggest ones.
First up is machine learning, and the source material has this really great analogy for it. Machine learning is all about discovering knowledge by finding patterns in training data. It is literally like a child learning to read. Think about it. You point to a letter on a page and tell a toddler, that's an A. After showing them enough examples, they're going to recognize an A, whether it's handwritten, printed in a book, big or small. Machine learning works the exact same way. You feed it a bunch of labeled training data, like thousands of pictures of handwriting, and it learns the underlying patterns so it can correctly identify a brand new, never-before-seen letter.
Then we've got natural language processing, or NLP. This branch is all about human language. If you've ever used voice-to-text to send a message, deposited a check using handwriting recognition on your phone, clicked translate on a foreign website, or honestly just Googled something, you are using NLP. It is the absolutely crucial bridge that lets machines process, understand, and even generate human communication.
Finally, let's talk about expert systems. These are programs specifically designed to process massive amounts of highly specialized information and simulate the analytical skills of a human expert. Remember Mycin from earlier for medical diagnosis? Another awesome example from the text is Dendral, which determines molecular structures from chemical formulas. These systems essentially take the genius-level knowledge of a top doctor or a master chemist, turn their decision-making process into a system of rules, and make that expertise instantly scalable and available through a machine. It's like having an expert on call 24/7.
And that brings us to one final thought I want to leave you with. We started off today by comparing AI to the invention of the airplane, focusing on the soaring results rather than trying to perfectly copy nature. We've seen how this idea evolved from simple on and off switches in the 40s to these incredibly robust systems today that can diagnose illnesses, translate languages on the fly, and learn patterns just like a child. So knowing just how far this flying machine of the mind has already come, what complex human task do you think AI is going to master next? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.